Hey, what's going on, everybody? Today is June 13th, 2024, and you are watching the Daily AI Show live. And today we're talking about, can frontier AI models keep growing at a 5x per year rate? And with us today, we have Junmi, Andy, Beth, and I'm Brian. We'll see if anybody else hops in the door from the crew. And this conversation today comes from a blog, basically, or research article, but it's a blog from epicai.org, and that's EPOCHAI.org. We'll share that, make sure it's up on the screen as well. And they put out a report called Training Compute of Frontier AI Models Grows by 4 to 5x per year. And then their subtitle here says, our expanded AI model database shows that the compute used to train recent models grew 4 to 5x from 2010 through May of 2024. We find similar growth in frontier models, recent large language models, and models from leading companies. So I think before we get too far into this, there's two big definitions that we have to make sure that we sort of hit first. Frontier models, as defined by Epic in this case, and also compute. So let me start with compute. And I pulled this up because I get, honestly, look, we're all learning with everybody. I get confused on this stuff sometimes too. And I'm like, I'm pretty sure that it's flops. It is, but so learn with me here. So compute is often measured in flops. Flops stands for floating point operations per second, which quantify the number of calculations a system can perform. Training compute growth is tracked by considering the total number of flops required for the training process. For frontier models, we'll talk about that in a second, this has escalated dramatically, reaching levels far beyond what would be predicted by Moore's law, which traditionally estimated a doubling of compute capacities every 18 to 24 months. Now, most of us have heard of Moore's law. So interesting. This is ChatGPT, by the way, that I was pulling this up for. I gave it the Epic article and I said, help me understand this a little bit, right? And so it broke it out into three historical eras, which I thought were interesting and sort of fascinating. You have the pre-deep learning era, which it qualifies as 1956 to 2010. And this is where Moore's law applies, or it says it applies. Then you have the deep learning era from 2010 to 2015. Rapid increase with a doubling time of about 6 months. Large scale era, 2015 to present, characterized by the use of vast compute resources by large corporations, doubling every 10 months. So that's just sort of a quick background on compute, which then leaves us to, well, what are we talking about frontier models? And of course, I scrolled up on it. I'll probably have to, of course, frontier models, definition of frontier. Okay, here it is. Note that we use a different definition of frontier models in our previous paper. We now prefer our updated, simpler definition of frontier models as models in the running top 10 of training compute. This new definition has an advantage of being less sensitive to outliers and to the models with low compute, and we have found that it corresponds better with what we intuitively consider frontier models. Our new definition has consequences on the results we highlight, as the trend among frontier models, according to our new definition, is noticeably faster than with our previous definition. And then they go on to talk about how it ultimately, this Epic ultimately comes back to the idea of no matter where you look at it, and although there's comments that they bring up in limitations in different areas, that this 4 to 5x seems to hold true continuously. So that kind of gets us started on this conversation. So we're talking about, Epic is talking about frontier models, which we just defined as growing at 4 to 5 times X per year rate for compute. But what's also something we can bring up in this conversation is that there's other things that are factoring into how smart these language models are getting to. And we can get into that a little bit more in a minute, but there's actually a great paper that Ethan Malik shared on a LinkedIn post maybe a couple of days ago from situational-awareness.ai. And they break it down into 3 more sections, with compute only being one of them. So before I keep going into all that, I just wanted to sort of set the stage of what we're talking about. And really the question here is, now looking at Epic's data, now what they did is they went backwards and they said, does our prediction hold true if you were to go back? I thought they called it retro directing or something like that. It was a term I hadn't heard before. They started it at GPT-3 and essentially extrapolated forward, right, to see if that cone holds true. And in fact, it did. So if it continues to hold true, what does that mean for the future? And are we at a limit of compute? Are we at a limit of how efficient these algorithms can get, which is another part of it. And then something else called unhobbling, which is from this other report, which we can talk about as well. So set the stage there. I don't know. Let me throw it to you, Andy, because I feel like you always really help us understand the complex here. You're always sort of one of our go-to of like breaking down the complex into simple. So, what's your take on sort of like this report and what it made you think of going forward?
Yeah, thank you. This is looking in the rearview mirror, an analysis of history and what has been done to achieve advances in the capabilities of the frontier models, the very largest models. And so you can see that the cost of computing the pre-training of those models has been escalating as they make the models larger and larger in order to achieve more and more what I'll call, and it is generally called, emergent properties, including reasoning. So when you just remember all these models and this intense compute requirement of feeding it all the data from every source that you could possibly gather, like literally trillions and trillions of data points, all of that has to be fed through the current architecture of the large language models, which is transformer architecture. And that process is looking to predict individual next tokens. So every single piece of data has to be broken down into tokens, and it has to be fed through the model, and it has to go through many, many, many layers. The larger the model gets, the more calculations have to be done to cascade through that deep model. But this has been very, very effective, as you've seen, with each frontier model being larger than the last, having cost way more in compute, and demonstrating much more capable reasoning and broader knowledge. But that's just the architecture of what we've found is possible, and we're starting to reach limits in terms of the data and the practical application of our resources. And it doesn't really, if I look forward, it doesn't really require that we keep expanding the size of the models and using the transformer architecture to get to artificial general intelligence. So my prediction is that, and one of the things that's shown in the EPIC results is that there was a period of time when it was 9 times every year, and then it's kind of softened to 4 to 5 times a year. And I suggest that it's going to soften even more as a whole array of new methods is applied to the large language models, including totally new architectures that are beyond what transformers are capable of doing in single next token prediction, which is what the method is that we've used now. So I'm going to talk in a moment about something that's really hot in the news right now, coming from Meta and Jan LeCun, who's a proponent of a new methodology for approaching this whole expansion of models to achieve AGI. But let me just mention a bunch of other things that we've talked about on the show that are related to this. So one of them is, instead of training, another next token prediction model with enormous, like billions of dollars of cost, both in the hardware and the software, compute time and energy cost, there's this concept that we talked about called evolutionary model merge. So there's a technique you can use where if you take existing models and you merge them, the compute that's required to merge those models is a tiny fraction of what it costs to pre-train a new model. So we've demonstrated that evolutionary model merge is a method that can approximate the capabilities of the largest frontier models, but without anything close to the compute cost. So maybe that one method alone could do it, but there's others. Mixture of experts, Mistral, which just got its $640 million, B series, they demonstrated that by creating a gang of smaller models, you get very close to what is achieved by the very largest models. And then there's mixture of depths. We talked about this one, this is putting in the training process, putting the the LLM on a diet of tokens and forcing it to figure out higher order representations out of a smaller number of tokens being processed at each layer in all the many hidden layers of the LLM. And then just a few days ago, we talked about mixture of agents, which is, okay, now I don't really need to build one monolithic, huge next token prediction model. I can put a series of agents together, a series of models together is what they're meaning, and process the prompt through a succession of them, asking each one of these successive models to try to refine what the prior model did. So there's lots of different methods here. Let me talk now about what Meta's doing. It's called JEPA, Joint Embedding Predictive Architecture. This goes beyond next token prediction to predict multiple token combinations in the training process. And so what it does is it achieves efficiency gains by learning and predicting abstract representations, not just single tokens. So in doing that, it discards unnecessary details. Instead of giving it every single individual, and by the way, this has been done in video and audio primarily, and not on large language models, but the technology and the methodology there, I think, is applicable to the training of large language models. So it's designed to achieve the same level of accuracy compared to traditional single token prediction models, but it can do this across various modalities. And what it does is it predicts abstract representations, or like what's another word for it? So the abstraction is like, instead of one token, it's looking at, okay, there's semantic meaning in this area, and I'm going to learn that. And this whole process of JEPA, it changes the game to allow the models to learn meaningful features with less data. That's the takeaway here. So this is literally, in the last couple of days, I became aware of this. And then, Beth, you introduced another article that is related to these efficiency gains that has to do with refining the matrix calculation load that's involved in compute, right, by changing the math, basically, that's being used away from transformer math, which requires these massive GPU arrays in order to do the matrix calculations against all these hidden layers, and instead does it with a very different thing. Can you comment on that one, Beth?
So the big point of that paper was that what they refer to as MAT-MUL, which is the matrix multiplier, is not necessary, right? In this method, you can get similar results with far less far less of the compute needed to do that matrix multiplier process, right? So it's kind of like what you're talking about, Andy, as well. I feel like so if we look at the difference between what is considered quantum computing and what we're traditionally talking about in terms of binary, right? Binary is like it's a 1 or a 0. Right? And quantum is looking at the distance between the 1 and the 0 and working within that. And it feels like we are getting closer to that sort of thing in this, Andy. If we are looking at the patterns of what's happening, that is actually a little more of engaging in the shape of the whole and what is contained within it, the distances that are contained within it, as opposed to just the data points, right? Just the tokens. I find it really exciting. Carl, what do you got?
I'm honestly, I'm trying to look at it more so from like, what would a business think about this and how would they plan for this out? Because that's the question that I got from a prospect a couple of days ago, would be like, how do we plan this if the models get better? And I think I'm going to go back to Brad Lightcap a couple months ago, where he was saying, if you plan your business, either develop a program, develop your app or wrapper, or plan enterprise level business based on the static level of a model today, you will lose. Or either he said it in a very light manner, I don't know, I can't remember. And then I remember that the CTO, Microsoft CTO, was in front of a screen where it had GPT-4 and then 5 going up. And then every single time, Sam Altman has been saying, yeah, he does not see these models going, like, he does not see a plateau. He sees it going up and up and up. So I, just based on everything that they have said, I'm assuming even Ilya Sutskever, I think there was an article or something that he said is like, if you just put more compute to it, it'll just get better. We're not there from a scaling. So the question for business would be, how do I prepare if the model itself changes versus staying static? So an example would be, it's no longer text. It can see and hear. Now you have agents. Now you have this. Because I think the thing that always goes back to is like, most software stays static. Like the example he used was the iPhone. Sure, the apps have changed some of the functionalities, but you can still see it's on your phone. You tap the app, you swipe. It's the same concept. But this is a tool that changes as it goes. So you'll have voice, you have vision. So how does a business prepare for that? So that as the models get better, what can businesses and people do? Here's an interesting thing too. Yesterday, I was having a conversation with my in-laws, and we're talking about Parkinson's, and how you would have a conversation with your neurologists, and then you have to wait till your next meeting to have that conversation. But it's like, oh, ditch the conversation. Now you can just speak to this thing. And I'm not saying it's replacing a neurologist, but in the meantime, you can just have conversations and then speech therapy. Oh, what can you do there? So like the options grow, so it can't stay static. So as the models get better, the reasoning gets better. Isn't it like right now GPT-4o or 4 is a high school level reasoning? What happens when it's PhD level reasoning?
Right. And it's again, it's the relationship of that, right? So GPT-3 was the preschool level reasoning, and GPT-4 is the high school level reasoning. And the idea is that we are likely to see a comparable expansion in the next. And we can sort of go, okay, so is that PhD level? But then when you go the next, right? Do we have a concept of this? Paul Reitzer talks about this in terms of speed, that we don't have a really great sense of what exponential speed is like, right? So it's like the bike to the car to the airplane. But when you can you sense the speed in the airplane as dramatically different from the car? And then could you sense it if the airplane was going like 10 times faster than it was going, right? Like
that's cool analogy. Yeah, that's a really interesting analogy. And then obviously with what Apple did, then it's like it's built right into your device. So it becomes natural and then exponential. So we could all assume in 3 years what Apple Siri can do 10x, 20x, because now it can do, and then all the people who are building the apps. Because today I was like, oh, turn on TikTok. It works. But it's like, hey, I want you to turn on TikTok. I want to find this particular creator. And can you tell me about either the latest or this video that this person did 3 weeks ago about this? I'm assuming in a year, that's going to be easy to do.
Or even better, filter through it and, give me a summary of the last 15 AI related TikTok videos, but only the AI related one, not the other stuff that I filtered through. And give me a summary of that and help me better understand what I gained from that. That's kind of like saying in the past, you would have to have saved those in some sort of directory or bookmark or something, or a read later. And now that is going to start going away because that idea of read later won't be necessary with recall type functionality. It will always be able to bring it back to you later. It will always have the ability to say, yeah, you did ask a question about that 3 weeks ago. And in that 3 weeks, you've also viewed consumed, watched, whatever in social media or read these other 6 things. Would you like me to update where we're at from 3 weeks ago when we last had this conversation? Yes. Yes. I want this continuous conversation to keep going. And I think that will be, to your point, Carl, that'll be just easy. And if I can, I just want to go real back to your, because I love what you said about how do businesses need to be thinking about this. You're absolutely right. When you build a custom GPT, I just had this conversation with my wife this morning. She's getting ready to head out for, I keep talking about, she's going to be out in New York talking and doing her AI presentation. Well, that's finally here. And so we were talking this morning about custom GPTs, and she was just like, hey, help me just grab onto this concept real quick. I want to make sure I'm saying it right in my presentations. Great. So I just walked you through. I was like, look, it's a building block thing. I said, you have throwaway prompts like, what's the weather tomorrow, right? That'd be a throw. You want it one time or whatever. Maybe weather isn't a good one, but like a one-off answer. Hey, explain to me the difference between diabetes 1 and 2. Okay, that's a one-off answer. I'm probably not going to use that again. And then you have prompts that become into like prompt libraries, and you build them out, and they become custom GPTs. And custom GPTs now can access knowledge documents. And if you're a business, that you shouldn't be worried about building there, because you can say, oh, I can see how a custom GPT is going to get smarter, better. It's going to be able to access online documents. It's going to have live real time, like we were talking about yesterday. We can see these things sort of coming over the next hill. So that's where I think businesses should be focusing, is saying, what can I build today that helps my company? And maybe it only partially solves the problem. But if I just peek over the next hill, I could see how this same built solution today would have agentic qualities to be even smarter tomorrow, as opposed to let me build some one-off tool that takes a lot of time that ultimately becomes a spell check that gets washed over very quickly by the next iteration of AI abilities. And so I think for me, that's how I would, that is how I consult with other companies when I talk to them, is like, think about the types of solutions you can create today that can grow. And I think that's kind of what you're saying, Carl. Like, don't paint yourself in a corner. Make sure that you're coming up with AI solutions that, as AI gets smarter, your solution actually gets smarter along with it.
Yeah, you have to kind of plan that as you, and it's a very different mindset for a business, because it's like, oh, I bought Salesforce. This is what it's going to do. I expect it to do this. Sure, there's a bunch of new features, but generally it's going to be doing these things. Thing is, imagine if Salesforce, instead of like, it's not just, it changes its entire base feature. So now it's no longer just collecting your contacts. It actually goes out and contacts them for you. That completely changes what you're like, wait a minute, it does that? And like, so the type of change that we're looking for. What's fascinating to me is when Andy mentioned about, the less amount of data, there was something that said, like, by 2026, 2027, all the data that the humans have created before AI will have been gathered.
Yeah.
All the text.
All the text. And then the next round is the video data. The next round, like that, I'm sure in the next couple of years, that'll be scraped and consumed and all that. So I'm always fascinated about the concept of the curse of the recursion. There was a paper on that about, like, does the model get worse as you train it on its own data? Because that's what you're doing.
But that isn't what they found.
That hasn't, but I don't know. But then it leads you to think about, hey, wait a minute. I've always been a big proponent of, hey, here's an example. Can you make 30 examples of that? Like, can you make 30 things of this example? So technically, you're just given an example of a piece of data, asking it to recreate synthetic data based on your example. So if you train it on that, what happens? And I'm just really curious about that concept of an AI creating its own data to train against it. And then where does that go?
So that's a prompting technique that I'm using now, and that Rob Lennon talked about a couple weeks ago. And in fact, if you read our newsletter, and if you didn't, you should, some of those articles were written very much like that, where you do this few shot prompting, which we've talked about a couple times, and basically at a minimum you give both answers. So you give your prompt and then you give the answer of what the LLM would give you back, right? And you do that a couple times, and then you just give a new piece of information to react to. That is essentially fine. Like, that's a really tiny version of fine tuning or finding data to train on. And it is remarkably effective, and way more effective than, like, please write in a casual tone with 50% professionality that has worked with these people for 3 years, but has recently had, like, whatever that is that you're trying to describe the tone. If you just give it like, these are 3 examples of the tone, and you can fix what it gave you, right? You can set it up, you can rewrite it, then you could feed it back and say, wow, what a great job you did, let's do that again, right? Like, you can continue that process. It's really it's so much more effective in what I'm doing.
I want to tie what Carl was talking about to what you just said, Beth. So Carl's talking about us bumping up against the limits of the data that's available and the quality of that data, and having to, start to do training on synthetic data, which is generated by AI itself based on its understanding of example data. It's going to create new ones, and it has this capability. And Beth, you're talking about using a sort of representative examples, a higher order representation of what you mean when you want your response to be in this sort of concept space and presentation and format. So those two things together are beautiful examples of where we're bumping up against the limits of what data we have available, and also now exploiting the knowledge and reasoning that the large models already contain, and their ability to do analogy. So here's my example, and now it can generate a response based on new data inputs that you provide in the prompt, and do something that's quite similar to that, but is respecting lots of other governing sort of logic and reasoning that's out there. We talked also recently about FineWeb, which is this curated selection of data. So it's the 4 to 5 times thing that is the subject of this whole discussion. It started it out. That was because they were trying to do larger and larger data sets in training, and probably needed, as they stayed on that trajectory of training these very deep neural networks with data, to use some synthetic data. But FineWeb and the illustration of the quality of reasoning that comes out of FineWeb is a function of saying, no, don't give it every bit of data we ever generated in the world. Let's limit the data to the things that we've already determined are much better quality, particularly in specific knowledge domain areas. For example, in education, the FineWeb-EDU one generates a model that it's a selection of data that's really just scholarly data, not a bunch of junk on the internet. We reference The Onion as being part of what all these models were trained on, which is parity, but the models don't necessarily understand at the moment of training that this data that's being fed, whether synthetic or from a parody or from some really, questionable source, just hoovered up from the internet, it doesn't know how to discriminate those in terms of quality, but we do. And so we can, by very hard effort, curate the data. And that's another way that this progression of 4 to 5 times larger data sets and compute requirements and energy requirements will be curtailed over time. We're going to be much more parsimonious, let's say, about how much we feed these models in their pre-training.
Parsimonious. I'm gonna have to go chat GPT that word now. Thanks, Andy. Hey, on that topic, I want to bring up this point because you just mentioned it, Andy. And this is a article. This is a website, situational-awareness.ai. That again, Ethan Malik shared one of 3 documents he shared on a LinkedIn post the other day. And we'll reference that as well. By the way, if you want all the links and all the stuff we mentioned in the show, one of the cool things you can get when you sign up for the newsletter is if you refer one person, it unlocks the ability to get a spreadsheet where we share all of this. So if you always were like, man, they mention a lot of stuff, but it's hard to keep track of it, that's one cool way you can get all of this. But I will mention this one. It's situational awareness. And this is actually just like you can see it on the screen, like chapter 1 of this decade ahead. And I'm taking my time reading this. I don't want to Perplexity summarize this. I don't want to ChatGPT. I want to read every single word of this because I really, really am enjoying it. But the part that I want to bring up super quick is what we've sort of been talking about. Now, up until this point, we've been talking about compute because that's what Epic was talking about. Remember, Epic used compute or flops as sort of their gauge for the frontier models on are they moving at 3 to 5x. So this chapter 1 of this particular website talks about that as well, and also mentions, in fact, it mentions the Epic AI as well as a source, and talks about it moving at 5 times the speed of Moore's law. So we've talked a lot about compute, and there's some great graphics in here as well that are from Epic. But the next one I want to talk about is algorithmic efficiencies. And there's 3 here in this article. And I think these are all really, really important to understand, will it continue or perhaps even speed up at this 3 to 5x speed? And because what it's talking about is not only has compute increased, but the algorithms themselves have gotten drastically better at doing the work. So you're putting more power at it, right? You're putting more money towards it. You're spending now millions and now billions of dollars to increase compute and data centers. But also at the same time, the algorithms are getting massively more efficient. And so he's got, or she, I shouldn't say he, I don't know who this is actually that did this, has a great graph on here. Relative inference cost of 50% performance on the math benchmark. And so they're just showing back in 2022, relative cost was 1,000. I'm not sure what cost 1,000 what. I'm not sure on that one. But if you just watch the trend line, now Gemini 1.5 Flash, which is a few shot in July 2024, is effectively brought from almost 1,000, let's say 800, down to 1. And so this is just another example of how, these models are getting quote unquote better, if we could just throw that word on it. And the last one that is mentioned in here is something, and I highly recommend reading this whole deal, this whole article in the chapters, is something called unhobbling. And it says, it's what I call unhobbling. It says, imagine if you would ask or solve a hard math problem and you had to instantly answer with the very first thing that came to mind. It seems obvious that you would have a hard time, except for the simplest problems. But until recently, that's how we had LLMs solve math problems. Instead, most of us work through the problem step by step on Scratchpad, are able to solve it much more problems that way. So chain of thought prompting, unlock that for LLMs. So it goes on to talk about how things like reinforcement learning for human feedback, or RLHF, chain of thought, scaffolding, tools, context length, post-training improvements. These are all areas where we're not talking about necessarily compute or necessarily the algorithms get smarter, but these are, like, I guess you would call it unhobbling, right? These are ways that we've enabled these LLMs, these models, to work more efficiently. So I just thought it was a really great, like, kind of 1, 2, 3 punch on how to think about this. Because yes, compute is a big part of it. Obviously, Epic focused on that part, but with the increases on the algorithm and the efficiencies there, as well as all the things we just mentioned as far as the unhobbling, really, when you look at that, to me, there's no reason to expect a slowdown. There's no reason to expect it, especially when you look at the research that Epic has done. I would imagine in 2 to 3 years' time, we will see the same growth rate, which means, back to what you were talking about, Beth, they have basically said GPT-3 was like a preschooler, GPT-2 rather, maybe 4 and 4.0 are like a well-educated high schooler. And that's a 2 to 3 year run. So we're sitting in mid 2024, summer of 2026. We should be looking at LLMs that are postdoctorate, and maybe at levels that we don't necessarily understand in terms of comprehension, because it's starting to get to the point where we can no longer assign the smartest human we know. We can no longer say, oh, that's Einstein level of ability, because it will surpass that. And now there's no benchmark. There's no human mind or benchmark to say, oh, it's like this. No, it's beyond that. And now where do you go? And now how do you comprehend the speed at which it's getting smarter? If you can't, up until now, we've always been able to put a human, it's a high schooler, it's a PhD, it's a very smart PhD, it's Einstein, it's the smartest human that ever lived. And I think we're 2 to 3 years out from some of these LLMs far surpassing that level.
Yes. Darius Amades said something similar in the Ezra Klein interview. And in fact, it's like a very telling moment, because Ezra was like, what? Right? Like, needed a moment for the speed at which this stuff could happen. Junmi, what were you thinking?
Well, I want to just highlight what Brian was saying about the hobbling, because it kind of aligns with what Andy was pointing out about the various efficiencies and accelerators that are being developed and built for models in general. And we've talked about technologies or methodologies like Sakana, that does this evolutionary thing where, and then you have the mixture of experts and all of these things to increase the both the efficiency of compute use, or the lack of needing that extra compute, and equating that to levels of performance or increased performance. Now, I want to link this back to what the original question was, is if it can keep growing, right? And we've identified that the article was talking about specifically compute, right? If we're talking about the ability for models and AI to just become more powerful, I don't think that's a question. I think everyone understands that that's going to happen. Are we going to be able to grow and have higher performances, and like what you were just saying, Brian, like achieving intelligences far beyond that than we can actually label or compare to? I think that's also a given. I think what we're in the root of this, though, is can these models grow strictly from compute? Right. And some of the things that we have to identify there is a lot of physical or real world, hurdles, right? When we talk about just the sustainability of chip manufacturing, chip design, getting, those kinds of bottlenecks. I hear that a major bottleneck is a memory issue, right? That has not expanded. The bandwidth and the speed of that memory hasn't expanded to meet these requirements over the last few years. And so that's also a major bottleneck. So all of these, there's all these hardware and real world hurdles that we have to address as well. And we've talked about the major tech companies announcing that they want to go full sustainable energy production by 2030, and these other elements. Just to give a bit of environmental impact, we're talking like to train the largest AI models. A single model, when it comes to that training, has a carbon footprint of 600,000 pounds of CO2. That's essentially the same as, I think it was the lifetime use of like 5 or 6 cars or something like that on the road. So this is a lot, right? And so I think we have two components here. We have the capabilities and the efficiencies and everything on the software side. But in the hardware real world side, the sustainability side, that's something that needs to be addressed. And I think one of the major key points is we still have a single point of failure. Like, when our logistics pipelines got hit, a couple of years ago, essentially breaking down, and tied with COVID and all those kinds of things, we recognize that, our logistic lines are not particularly robust. Right. And one of those things is chip manufacturing. We got one major manufacturer, TSMC, in Taiwan. Right. And so we've been in a geopolitical balance for that for decades. Right. And so while that is being addressed by trying to build more more manufacturing centers and more data centers and things like that, I think we have to look at our logistics pipeline as an overall. And how does that tie in with what, like Carl was saying, is our business, our businesses and our audiences, businesses, and things like that. And I think when Carl, you mentioned what can a business do to adapt or take a look at their business on whether the new model would change anything, I think that's telling. I think we need to identify what is these real world sustainability issues. What we can already see what these huge advancements in AI, and that's going to be every year, pretty much from now on, what can they do to adapt to that? And I think you have to take a holistic view of the entire ecosystem to make those choices. And of course, identify what your business is, right? Because most businesses aren't AI businesses. They're a business that uses AI, right? And we've talked about that and we've heard about that. So I just wanted everyone to take a holistic look at the entire ecosystem when it comes to AI, and then you can identify where those hurdles or bottlenecks might be. And I think that could really inform, if we're just talking about AI model growth, can it sustain that 5x? And I think just in general growth, yes, we're going to see the sustain in 5x overall. The compute, that might be a sector that we need to pay more attention to so that it can fill in the gap, so to speak. Because I think that's what the article is identifying.
I just want to put one thing here, though, and I think it's more of a personal frustration for all of us. It's more of, hey, yeah, that's great that these things can, come out 5x. When get it into our hands, because you can announce anything that you want, as great as it is, conjecture, hints, it won't matter unless we actually get to use it. So I think that's the big thing, right? And in our newsletter, we actually have a countdown of all these things that are being released and how many days it's been since it actually gets into people's hands. So that's to me one of the exciting parts of our newsletter, because once you get it, you're like, oh, it's now been 50 days since this announcement. It's now been 100 days since this announcement, and no one has gotten it.
Yeah. Oh yeah.
We'll wrap it up there. Thanks for hanging out with us today. Thanks for all the comments. Thanks, Jen, and everybody else, Cindy, for joining us. And don't forget to, if you're enjoying this, if this is the first time you've heard about us, we would love it if you would subscribe. We do daily shows like this, 5 days a week. We're now well over 230, something like that, Jimmy. So we're doing this every day. So you can go to the dailyaishow.com to check out, any of the links into the podcast platforms or YouTube or LinkedIn. You can also sign up for the newsletter there. Tomorrow, we're going to be talking about, we're going to be doing a tool review, and it's going to be about Canva's new AI features. Now, they've had AI features, but they just had a sort of a show, or like an announcement. They call it their glow up, and they've increased and improved their AI tools. So it's about time to sort of look back at what they've done, decide whether we think they're valuable, give you our best, review of it, and whether we think it's valuable to you and your company. Maybe it's something you haven't looked at before. Perhaps you should, based on what it can do for AI and how it can help you with efficiencies of your company. So that'll be tomorrow. Until then, thanks everybody for hanging out, and we'll see you then. We'll see you next time. Bye.
Hello.